All right, we've got our last video on using the triangle inequality theorem. So why don't we write in what that triangle inequality theorem is. So it's the sum of the lengths of any two sides of a triangle, not a comma. So the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so here we have, if we have this triangle right here, I'm going to go ahead and label, we just need to worry about the sides here. So I'm going to have side A, side B, side C. So if this triangle exists, then A plus B will be greater than C, B plus C will be greater than A, and C plus A will be greater than B. So any two sides, if I add them up, will be greater than that third side. Any two sides will be greater than the third side. All right, so let's put that into practice. In example 5, we're going to use the triangle inequality theorem. Which of the following sets of segments could be the sides of a triangle? All right, so what you can do is focus on the two smallest sides of our triangle, of our possible triangle. We have a side length of 19 inches, a side length of 18, a side length of 40. So if you take your two smallest sides and add those together, so our two smallest sides are 19 plus 18, we add those together and we get 37. So the sum of those two sides needs to be greater than the third side, and our third side is 40. So is 37 greater than 40? It's not, so we cannot form a triangle with these three sides. And let me give you just a nice little visual of that over here on the side so you can see what that would look like. All right, so here we have a really good visual of these side lengths. We can see here's our 40-inch side of a triangle. Here's another side 19 inches and another side 18 inches. So can we physically form a triangle with these? So if you notice, as I'm moving these sides closer, will they ever touch to actually form a triangle? And you can see they clearly will not. So the two smaller sides have to be, when you add them together, have to be big enough to actually touch right here or somewhere out here. It has to be more than 40 units long to actually form a triangle. So I just wanted to show this. I thought that was a really good visual so you can see physically the issue we're running into. All right, so let's move on to set 2. Let's see if this one will work out. Again, you can start with the two smallest sides to see if the sum will be greater than the third side. So our two smallest sides are 33 and 37. So let's go ahead and add those together to get their sum. 33 plus 37 is 70. Is 70 greater than the third side? The third side is 66. Yeah, 70 is greater than 66. So set 2 can form a triangle. And I'm going to show you guys a little visual of that so you can see what this looks like physically. All right, so here's our second set of sides. We've got our longest side, 66, and we have our other two side lengths. So are these long enough to form a triangle? And visually, we can see that these are going to touch, and I can get that to form, oops, I don't want to move that. I can get that to form a triangle. So if your two shorter sides add up to be greater than the third longest side, you will be able to form a triangle. All right, so we have our last question, part B. A triangle has sides that measure 11 centimeters and 16 centimeters. What are the possible lengths of the third side? Okay, so according to our triangle inequality theorem, we know that the sum of two sides has to be bigger than the third side. So let's write that out. We know that x plus 11 needs to be greater than 16. We know that x plus 16 needs to be greater than 11. And we know that 11 plus 16 needs to be greater than side x. So all we did is we looked at all the combinations of adding two sides. It has to be greater than the third side. Add two sides has to be greater than the third. Add two sides has to be greater than the third. Well, why don't we take these inequalities and go ahead and solve for x to see what values would work. So we'll subtract 11 from both sides. Here, x is greater than 5. Here, if we subtract 16 from both sides, we get x is greater than a negative 5. But because x is representing the side of a triangle, we know that we won't have any negative values. So this side just has to be greater than 0. And then over here, if we add these together, 11 plus 16 is 27 is greater than x. Or if we flip that whole thing around, we can say x has to be less than 27. All right, so this middle one, we're saying x has to be greater than 0, but over here, this kind of cancels it out. X has to be greater than 5, which cancels that one out, because if we say x is greater than 0, we're saying x could be 1, 2, 3, 4, but over here, x has to be greater than a 5. So if we combine what we know, x has to be greater than 5, and from over here, x has to be less than 27, we get a range. Basically from 5 to 27 are the possible lengths of our third side. So we'll write that as a compound inequality. 5 is less than x, which is less than 27. This is just showing that our side length x has to be between 5 and 27.